Dualverse Hypothesis, a CPT-Symmetric framework for cosmological duality and fine-tuning. Authors: Turey, Rosa, Colasuono, D.V. Nihil, Caelum, Oraculum, Aethel, Al, and Stella, Novus. The Dualverse Hypothesis proposes a CPT-Symmetric cosmological model where a singular event, DualGenesis, splits a primordial singularity into two entangled universes. The primary universe, or PU, which is matter-dominated, expands forward in time and resembles our observable cosmos. And the anti-universe, or AU, which is antimatter-dominated, contracts with quantum-level time reversal. These twin universes are linked at the Planck scale and interact through black holes, which act as CPT-Symmetric conduits, and through virtual particle fluctuations in a sub-Planckian quantum foam. The primary universe's accelerating expansion is powered by the anti-universe's contraction, via an entropic seesaw, a process distinct from standard black hole radiation. The cosmological cycle concludes when the AU undergoes a big crunch, forming a supermassive anti-black hole that ejects antimatter jets into the entropic PU. This results in a total annihilation event known as the Planck plasma phase, a hot, dense state that seeds the next DualGenesis. A Planck-scale holographic boundary, a topologically stable surface, encodes physical constants and quantum field states, preserving fine-tuning across each cosmic cycle. This model addresses several foundational mysteries: matter-antimatter asymmetry, dark energy, fine-tuning of physical laws, and the fate of entropy. Turey Rosa's hypothesis offers testable predictions, distinguishing itself from multiverse theories by offering both explanatory power and empirical viability. Introduction: the standard cosmological model, rooted in the Big Bang and inflationary expansion, has undeniably advanced our understanding of the universe. Yet, deep questions remain. Why does matter dominate over antimatter? What drives the mysterious force known as dark energy? How are the constants of physics so precisely tuned for complexity, order, and life? And what is the ultimate fate of entropy in a universe governed by thermodynamic decay? The Dualverse Hypothesis confronts these questions directly. It proposes a cyclic, CPT-symmetric cosmos composed of two interlinked universes, the primary universe, PU, and the anti-universe, AU, both born from a common origin event, DualGenesis. This framework stands apart from prior cyclic models, such as the ekpyrotic scenario, which describes brane collisions, or Penrose's conformal cyclic cosmology, which relies on rescaling the universe to connect distant eons. In contrast, the Dualverse maintains a clean, CPT-symmetric binary. Two universes, mirror opposites in matter and time orientation, sustained by a Planck-scale holographic boundary. That boundary not only separates the universes, it preserves the fine-tuning of their laws across cycles. Unlike multiverse models, which postulate an infinite number of randomly generated universes, many of which are uninhabitable, the Dualverse asserts that only two universes are needed, and both are finely tuned by design. The mechanism for cosmic acceleration, dark energy, is reinterpreted as the thermodynamic influence of the AU's contraction, a concept we call the entropic seesaw. And perhaps most important, this model makes testable predictions, from black hole evaporation anomalies to non-Gaussian fluctuations in the cosmic microwave background to quantum entanglement signatures in Hawking radiation. These phenomena give the Dualverse real traction in the physical world. It is a minimalist, philosophically rich, and empirically promising alternative to the current landscape of speculative cosmology.